Good day, students! You're now at the second module for the course General Mathematics. Last module, you have learned about the introductions of functions, evaluating, operations, and composition. Get ready to nourish your minds because for today's video, we will be talking about finding the domain and the range of the functions. First and foremost, let's have a recall about the definition of the domain and the range. Let's have domain. Domain is the set of all possible input values, often the x variable, which produce a valid output from a particular function. Range is the set of possible output values, usually the variable y or sometimes expressed as f of x, which result from using a particular function. Let us try to do this one. Determine the domain and range of a function. Let's have a first. A is the set of 1 and 2, 2 and 3, 3 and 4. The domain of the set A are 1, 2, and 3. And the range are 2, 3, and 4. Let's have letter B. The x values are negative 4, negative 1, 3, 6, and 9. And the y values are 16, 1, 9, 36, and 81. The domain for letter B are negative 4, negative 1, 3, 6, and 9. And the range are 1, 9, 16, 36, and 81. Let's try letter C. S is the set of 6 and 2, 4 and 2, 2 and 2. The domain of the set S are 2, 4, and 6, and the range is 2. Remember that when the number is being repeated, you will only write it once. Just like the range of the set S, which are 2, 2, and 2, since 2 is being repeated, all you have to do is to write it once. Letter D. Negative 4 maps to negative 2, positive 5 maps to negative 3, and positive 2 maps to positive 4. The domain for letter D are negative 4, positive 2, and positive 5. And the range are negative 3, negative 2, and positive 4. Always remember that in writing the domain and range of a function, you have to write it in ascending order. Without further ado, let's begin. In determining the domain and range of a function, it is important for you to identify first whether the given is or are polynomial, rational expression, or radical expression. Let's now have finding the domain of a polynomial. But before that, let's have the definition first of a polynomial. A polynomial is an expression consisting of variables and coefficients that involves only the operations of addition, subtraction, multiplication, and non-negative integer exponentiation of the variables. In finding the domain, whether the given function is or are polynomial, rational expression, and or radical expression, you always need to solve the equation for y in terms of x, or in some other books, it is called as y form. Let's begin. In finding the domain, if the given function is our polynomials, the domain is the set of all real numbers. To further understand that, let us have examples. Example number 1. F of x is equal to x plus 5. Our first step in finding the domain of a polynomial is change f of x to y. So our resulting equation will be y is equal to x plus 5. Next, solve the equation for y in terms of x. One tip about that, when we say solve the equation for y in terms of x, another term for that is so-called y form. So, if the resulting equation is already in y form and it is polynomial, therefore, the domain is the set of all real numbers. In symbols, domain is equal to x such that x is an element of all real numbers. Let's have number 2. F of x is equal to negative 2x minus 11. So same goes with what we did with example number 1. Change f of x to y. So our equation now will be y is equal to negative 2x minus 11. Next thing you will do, solve the equation for y in terms of x or the y form. Question: is the equation already in the y form? If yes, and it is polynomial, hence, the domain is the set of all real numbers. In symbols, domain is equal to x such that x is an element of all real numbers. Let's have another example, number 3. F of x is equal to x squared plus 5. So same process, change f of x to y. So our equation now will be y is equal to x squared plus 5. Then, solve the equation for y in terms of x or the y form. If the equation is already in y form and it is polynomial, therefore, the domain is the set of all real numbers. Again, in symbols, domain is equal to x such that x is an element of all real numbers. So if you will notice from the given examples, the defining equations are already expressed for y in terms of x. Since y are all polynomials, its domain are all set of real numbers. So let's have a bit challenging example. Let's have number 4. 2x squared plus 2y plus 4 is equal to 0. Don't panic. Let's do it one by one. Again, change f of x to y. So as you can see, since there is no f of x in the given, we can now proceed to the next step, which is solve the equation for y in terms of x or the y form. Let's write the given. 2x squared plus 2y plus 4 is equal to 0. Next thing to do is that add both sides by negative 2x squared through addition property of equality. Why negative 2x squared? It's because our goal here is to isolate variable y on one side. If we add negative 2x squared both sides, on the left side of the equation, you will get 0 as the result of 2x squared minus 2x squared. Or, you can already proceed to cancellation. So, the resulting equation now is 2y plus 4 is equal to negative 2x squared. Again, our goal here is to isolate variable y on one side. Therefore, we need to add both sides by negative 4 through addition property of equality. So, our equation now is 2y plus 4 minus 4 is equal to negative 2x squared minus 4. So, 4 minus 4 will be equal to 0 or already cancel. So, our resulting equation now will be 2y is equal to negative 2x squared minus 4. We're not yet done. Since there is numerical coefficient 2 in the variable y, we need to get the reciprocal of 2. and that is 1/2. Next thing to do is multiply both sides by 1/2 through multiplication property of equality. And that is to isolate variable y on the other side. So our equation now will be 1/2 times the quantity of 2y is equal to negative 2x squared minus 4 times the quantity of 1/2. If you can still remember the rule in multiplying fraction to a whole number, all you have to do is give the whole number a denominator of 1. So that would be, our equation now will be 1/2 times the quantity of 2y over 1 is equal to negative 2x squared over 1 minus 4 over 1 times the quantity of 1/2. Then, since it's both fraction now, apply direct multiplication. How? Simply multiply numerator times numerator, then denominator times the denominator. So on the left side of the equation, 1/2 multiplied by 2y over 1. So that would be 1 times 2y, that would be 2y, 2 times 1, that would be 2. So on the left side of the equation, it will be 2y over 2. Next, on the right side of the equation, distribute 1/2 to negative 2x squared over 1 minus 4 over 1. So 1/2 multiplied by negative 2x squared over 1. So 1 times negative 2x squared, that will be negative 2x squared. Next, 2 times 1, that would be 2. So that would be negative 2x squared over 2. Next, multiplied 1/2 to negative 4 over 1. So that would be 1 times negative 4, that would be negative 4. Then 2 times negative 1, that would be negative 2. So it will be negative 4 over 2. Next thing to do, simplify. So on the left side of the equation, 2y divided by 2, that is equal to y. And on the right side of the equation, negative 2x squared divided by 2, that is equal to negative x squared. And the last, negative 4 divided by 2, that would be negative 2. So the resulting equation now is y is equal to negative x squared minus 2. Is our equation now already in solving y in terms of x or in the y form? If yes, and it is polynomial, therefore, the final answer is domain are all set of real numbers. In symbols, domain is equal to x such that x is an element of all real numbers. Any more question about finding the domain if the given function is our polynomials? If none, let's move on now with finding the domain if the given function is our rational expressions. Let's now have finding the domain of a rational expression. So a more concise definition of rational expression is nothing more than a fraction in which the numerator and or the denominator are both polynomials. So, in finding the domain if the given function is or our rational expression, the domain is the set of real numbers except those values of x that makes d of x equal to 0. So to further understand that, let us have examples. Let's have number 1. F of x is equal to 1 over x. Same process. First step is change f of x to y. So our equation now will be y is equal to 1 over x. Then next, solve the equation for y in terms of x. or the y form. If the resulting equation is already in the y form and it is in rational expression, the domain is the set of real numbers except those values of x that make d of x equals to 0. In symbols, domain is equal to x such that x is not equal to 0. Let's try another example, number 2. F of x is equal to 1x plus 5. So again, first step, change f of x to y. So that would be y is equal to 1 over x plus 5. Then, solve the equation for y in terms of x, or the y form. If the equation is already in the y form and it is rational expression, therefore, the domain is the set of all real numbers except those values of x that makes d of x equal to 0. In symbols, domain is equal to x such that x is not equal to 0. Please take note of this, our dear students. In finding the domain of a rational expression, the denominator must not be equal to 0. Because if that happens, the domain will become undefined. Any more question about finding the domain of the given function if it's rational expression? If none, let's move on now with finding the domain if the given function is radical expression. Let's now have the last one, finding the domain of a radical expression. So let's have the definition first of a radical expression. A radical expression is any mathematical expression containing a radical symbol. So that is the radical symbol that you can see on your screen. So that is how you will be identifying radical expression. In finding the domain if the given function is or are radical expression, the domain is the set of real numbers that make r of x greater than or equal to 0. Please be mindful with these notations that you can see on your screen. So the first one is the symbol for the greater than. Next is the less than. The third one is equal. Then the fourth one is less than or equal to. And the last symbol is greater than or equal to. Let us try some examples here. Let's have number 1 example. F of x is equal to square root of x plus 5. So same thing with what we had with the first two, the polynomial and rational expression. First step is to change f of x to y. So our equation now will be y is equal to square root of x plus 5. Next thing to do, solve the equation for y in terms of x, or the y form. So, if the resulting equation is already in y form and it is radical expression, focus now on the radicand.
Inequate
to 0. Because our restriction for the domain or the value of r of x, it must be greater than or equal to 0. So the resulting equation now is x plus 5 is greater than or equal to 0. Again, our goal here is to isolate variable x on the other side. So, we need to add negative 5 both sides.
Addition property of inequality.
So, the resulting equation now here is x plus 5 minus 5 greater than or equal to negative 5. On the left side of the equation, simplify positive 5 minus 5, and that is equal to 0. Or you can already proceed to cancellation. So our resulting equation now will be x is greater than or equal to negative 5. Therefore, the domain is the set of real numbers greater than or equal to negative 5. In symbols, domain is equal to x such that x is greater than or equal to negative 5. Next example, example number 2. F of x is equal to square root of negative x plus 9. So same process, change f of x to y. So our resulting equation now will be y is equal to square root of negative x plus 9. If the equation is already in y form and it is radical expression, focus now on the radicand.
Inequate.
To 0. So the resulting equation now we have is negative x plus 9 is greater than or equal to 0. Again, our goal here is to isolate variable x on the other side. So we need to add negative 9 both sides
Addition
through.
property of inequality.
So our resulting equation now will be negative x plus 9 minus 9 is greater than or equal to negative 9. We are not yet done, since the variable has its negative sign. Always remember, with regards to any variable, there is always an invisible numerical coefficient of 1. Do not be confused, ha? We usually don't write it anymore, but it's understood that it has a value of 1. Gets? If yes, going back, so to make the variable x become positive, we multiply it by negative 1 using multiplication property of. So our resulting equation now will be negative 1 times the quantity of negative x is greater than or equal to negative 9 times the quantity of negative 1. So from the left side of the equation, multiply negative 1 to negative x, so it will become positive x. So negative 1 multiplied by the inequality symbol, which is greater than or equal to, it will become less than or equal to. And on the right side of the equation, multiply negative 1 to negative 9, that will become positive 9. So our resulting equation now will be x is less than or equal to positive 9. Remember that we will only do this when we are solving any variable having a negative sign on it. So refer to the given example. So from greater than or equal to symbol, when you multiply it by negative 1, it will become less than or equal to symbol. So just like on the previous example number 1, since the given variable is already in positive, we don't need to change the inequality symbol anymore.
In symbols, domain is equal to x such that x is less than or equal to positive 9.